Okay, now let's look at the classical or logical approach for developing probabilities. Okay. The first one that we saw previously was the empirical approach, where we collected data from the experiment and we calculated relative frequencies. Okay, so now let's look at an experiment again. You remember, experiment is something that is, we're not talking about scientific experiment here. We're talking about, in the context of probability, it is anything that will result in a number of, result in any one of number of possible outcomes. So activity that results in one or one of in one or activity that results in one of a number of possible outcomes. Then there is another concept that goes along with hand in hand with the experiment, that is called sample space. Sample space is just a list of all the possible outcomes. So that will be like if we're talking about tossing a coin, then, and assuming that there are only two possible ways in which the coin can land, then the sample space will be head or tail. Two values in the sample space. If it is a six-faced die, each face having a number 1 through 6, then the sample space will be 1, 2, 3, 4, 5, 6. Now n then is the number of outcomes in the sample space. Okay. All right, so now the probability of a given outcome in that experiment, okay, is the any outcome. Okay, if it is just one outcome, then it will be 1 over n. Okay, for an outcome, so what we need to, so the probability of an outcome then is the number of ways in which that outcome can occur in the sample space. We have a list of possible unique outcomes, right? So the probability of the outcome that we are interested, okay, you look at all the unique outcomes and see how many of them would result in the outcome that you are interested in. Okay, for example, rolling a die, right? 1, 2, 3, 4, 5, 6. Suppose if the probability that you are interested in is an even number, the outcome that we want is an even number, then we have 3 possibilities in that die. Okay, so that divided by the total number of possibilities, that will give us the probability of the outcome. So number of ways the outcome can occur in a single trial of the experiment divided by n. Okay, let's look at a specific example, toss of a coin, right? So what is the experiment? Toss a fair coin. That's the experiment. So then what is the sample space? Head or tail. Then what is the n? Is 2. So the number of ways heads can occur in one toss, there's only one way, then probability of head is 1 over that, 0.5. And if you want to display that 0.5 as a fraction, you can go to format, right, number, and then there is fraction right there. So that will display the number as a fraction. And what is the number of ways in which tail can occur in one toss? Again, that is 1. So the probability of tail, so that should be t, probability of tail will be the same thing, 1 over n, and we can represent that as a fraction as well. So if H stands for head and T stands for tail, then this probability is that, and tail probability is that. So now you see the two probabilities sum to 1. Okay, we'll align it on that side. And what we have here is called a probability distribution. So for something to be a probability distribution, you must have the entire sample space, which means unique outcome, all the possible unique outcomes, and then a probability associated with each of those outcomes. And the two basic probability rules must be satisfied. Then what we have is a probability distribution. So this is what we call classical way of assigning probabilities.